For the last century, the world of automotive transportation has been dominated by gasoline and diesel internal combustion engines. Now, due to the recent oil crisis, the world is transferring over to hybrids and electronic vehicles. This prompts the need for electronic batteries that have a long range and can stay in a car for years and years on end without failure. As the years go on, through 2015, as you can see by the chart, the need for automotive batteries is increasing steadily. And as we get more towards the electronic vehicle, the need for batteries in electronic vehicles will also increase heavily. The world has put pressure on scientists to create new and advanced batteries that can both fuel our electronic vehicles and our hybrid vehicles. Consumers are looking for batteries that have almost endless range, quick refuel times, last forever, and have no failures that can cause in fires or other dangerous situations. Obviously, this is best case scenario, but scientists are pushing to find the best batteries possible for the use in hybrids and electronic vehicles. This means there are dozens and dozens of different types of batteries that are currently being researched. The scientists are looking for anything that they can possibly find that will give them an edge. But for demonstration purposes and comparison purposes, we're going to be looking into 5 different types of batteries. The traditional lead-acid batteries, absorbent glass matte batteries, lithium-ion type batteries, nickel metal hydride batteries, and the prototype semi-solid flow cell batteries. The lead-acid battery is the conventional battery found in almost all gasoline or diesel-powered internal combustion engines. This battery powers the starter, the electronic devices, stereo, and PCM of the vehicle. In addition to these, the battery also provides backup power to run the engine. This battery is found in almost every vehicle on the road to date. This is mostly because it is extremely cheap to produce, recyclable, and relatively safe. The lead-acid battery is actually the most common battery found in electronic vehicles. However, it is the most common battery because it is found in most do-it-yourself electronic vehicles because of its low cost. Unfortunately, the lead-acid style battery does not show much potential in production vehicles for hybrids or electronic vehicles down the line. It's extremely heavy, and packing enough batteries into a vehicle for it to power the vehicle to the required length, roughly 100 miles, without a recharge, the battery would weigh the car down so much that the car would become slow and inefficient. They also have a short life cycle relative to other styles of battery and cannot be used as long as, say, a lithium-ion battery or nickel metal hydride battery. In addition to this, they also have to be mounted straight up because they are filled with fluid, the acid, and if they are mounted on their side or other creative ways, they may leak and cause future issues in addition to becoming unusable. So because of these reasons, the lead-acid battery is just not usable within the automotive world for hybrids and electric vehicles. Absorbent glass matte batteries are similar to the traditional lead-acid battery, except that they're sealed and maintenance-free batteries. The absorbent glass matte battery is a lead plate battery with lead plates that are covered in fiberglass and then soaked in acid. This allows the batteries to be mounted anywhere. Unfortunately, they're just as heavy as lead-acid batteries. They're more expensive than lead-acid batteries and hold less power than the lead-acid battery does, which makes them also unuseful in production model electronic vehicles and hybrids. The lithium-ion battery is actually used in a lot of hybrids and electronic vehicles to date, most notably the Chevy Volt. The lithium-ion battery stores the most power per kilogram of any other battery currently used in the automotive world, with about 150 watt-hours per kilogram. This is compared to 100 watt-hours per kilogram of the conventional nickel metal hydride battery, and only 25 watt-hours per kilogram of the conventional lead-acid battery. The lithium-ion battery can store tons of power, holds its charge for significant lengths of time, up to multiple years without a major loss, and is generally the lightest battery used in automotive applications. Unfortunately, it's extremely sensitive to high temperatures and must be cooled at all times, increasing its cost. It must also be computer managed to be used properly, which adds more parts to the battery system, has a relatively short life cycle, 5 to 7 years, which also makes it needed to be replaced after 5 years of use, upping the cost of the vehicle over its lifetime. And unfortunately, the lithium-ion batteries have a tendency to burst into flames when they fail. This is very uncommon, but does happen, and has happened in the Chevy Volt before. The nickel metal hydride battery is very similar to the lithium-ion battery. It has high energy density at the lowest cost per watt over any other form, including the lithium-ion battery and lead-acid style batteries. The maintenance-free design has a very high capacity and can mount anywhere in the vehicle at any position. Unfortunately, the nickel metal hydride battery is more harmful to the environment when produced and recycled than any other battery. It has extremely long charge times, up to 12 hours for a full charge, and cannot be charged to their full potential without significantly lowering the life cycle of the battery. The life cycle is roughly 10 years. It has a very high cost and does need to be replaced every 10 years, adding to the cost of the vehicle over its life. The semi-solid flow cell battery system could revolutionize the way we think about batteries. It's a particle system that uses solid particles suspended in a carrier liquid held in two separate tanks, one with an anode, one with a cathode, that is then pumped through the system to either sides of a membrane which captures the electrical charge stored within the tanks. It's a very low-cost system, said to have unlimited range because it can be refueled just like a gasoline engine, and it also can be charged with like a standard battery with a wall plug-in. Still in its production phase, has not been put into mass production, and is just being tested, and would require worldwide addition of pumping stations. But it's a very good idea and could become a standard down the line. So which battery is the right battery for future hybrids and electric vehicles as our world transfers away from the internal combustion engine to electric powered motors? Really, there's no right answer. It's much too early to tell. Over the next 10 years, the world will develop so much new technology that we could create completely new batteries that perfectly meet our needs. Some people think that the lithium-ion battery and nickel metal hydride batteries will gain enough technology to be used and meet every need that the consumer desires. Others think that the flow cell style batteries that can be refilled at any time and also recharged is the perfect option for our hybrids and our electric vehicles as well. But really, it's too early to tell, and as time goes on, the technology for all of these batteries will increase, and that will really decide which battery is best for our world.